Hello everyone, welcome back to more Advent of Code. We're doing 2020 day 18 today. Day 18, operation order. As you look out the window and notice a heavily forested continent slowly appear over the horizon, you are interrupted by the child sitting next to you. They're curious if you could help them with their math homework. Unfortunately, it seems like this math follows different rules than you remember. What do we need a link for? I'm not going to watch a YouTube video on camera, I tell you that. The homework, your puzzle input, consists of a series of expressions that consist of addition and multiplication in parentheses. Just like normal math, the parentheses indicate that the expression inside must be evaluated before it can be used by the surrounding expression. Addition still finds the sum of the numbers on both sides, and multiplication still finds the product. However, the rules of operator precedence have changed. Rather than evaluating multiplication before addition, the operators have the same precedence and are evaluated left to right regardless of the order in which they appear. For example, the steps to evaluate the expression 1, 2, 3, 4, 5, 6 with some pluses and times. We're building a tree that's right biased, or I don't know, is this called left biased? Whatever. Regardless of which operators are put in here. So this entire left half is the argument is the first argument to plus, and the second argument is 6, and so on down the line. And of course, you can add parentheses if you want to change that. Before you can help with the homework, you need to understand it yourself. Evaluate the expressions on each line of the homework. What is the sum of the resulting values? So, let's talk some about things that are happening today. First of all, our input is like, none of these expressions are outrageously large. They're all, too hard to do by hand. We could probably do any one of them by hand if we really wanted to, but doing all 380 of them is not so good, but they're all plenty small enough that a computer can handle them. So the main thing that I spent some time thinking about before getting to this video was, well, okay, first of all, good job we're doing today in Haskell, right? We're used to writing parsers, although we've been writing regexes, we're writing them in a parser style, and it's very, very easy to transition to do it writing parsers instead. You do need a parser for this. You can't just use regexes because this requires an unbounded amount of space. Like, I don't immediately see what about this will go wrong if we try to use a regular expression, but like I know that it will because this language is well known to not be to require like a pushdown automaton, which is more powerful than the deterministic finite automaton. So something would go wrong if we use a regex. Now, right, we're using parsers. But the question is, like, how do you ensure that you parse things in the right order? Or in the right leaningness, right? What do you do? Like, you're parsing this, and you have, say, some parser for expressions. And your expression parser, of course, says, okay, first consume an expression for the left argument. And then if it finds an operator, what should it do? Should it assume that the left expression is the argument for that thing? Or should it consume the operator and assume that that's like, anyway, it's a little bit weird. And it made me think about, I know, it's not weird, it's just like, it's been a long time since I thought about it properly. It made me think about like writing expression grammars properly in terms of the, the formal languages stuff that you learn in your compilers class or whatever, if you have a computer science degree. Do they do that in like computer engineering? I don't really know the difference. Certainly where I was, computer engineering was much more closely related to like electrical engineering, and they took some of our classes, but not all of them. So you might write down your language as like an Exper is an Exper plus Exper or Exper times Exper. And this is all very lovely. What? Void variable? I don't even know, how do you like abort a list error? I don't know. Get out of here. I'm not in any mode in my scratch buffer. Like, I mean, I don't know. I'm in this like Lisp interaction mode. This should parse as like closure, right? Yeah. But I'm just using it as text. I just don't understand how I. Exper is void? What? All right. I mean, obviously it's void. It's not defined, but I don't know why you would try to evaluate it now. Anyway. So this is fine, but when you parse an Exper, it's like hard to tell. You need look ahead kind of to just. Oh, actually, we should say. To decide which, like how far to parse this Exper before you consume the plus as part of your thing, right? I guess what we would be proper to do is say int or something, right? And then we say int equals yeah, this is the problem, right? That now that makes more sense. Int is you know, I don't know exactly what the typical notation is, so we'll just write this. So, you know, it's clear to you what int means. So once you've parsed an int, you don't know which of these three branches to go down. Clearly not this one, because it wasn't a parenthesis. But was it this one where the expression was just an int, or was it this one? You know, we could even like make things a little bit simpler and say like remove these, right? And say op equals plus or times. And this highlights the problem a little bit better. Which is, now that you've parsed an int, is it the end of this construction? Oh, what is that called? It's not called a constructor, is it? Terminal, non-terminal, symbol. I know int is a terminal, sort of, and well, I don't know. I guess properly int is sort of a non-terminal, but like if we had properly lexed so that we had each token as just like a single token, then int would be a terminal. So I guess we would write it like that. You know, is Exper an int? Is the int that we parsed part of this int terminal constructor, or God, it's not called constructor, it's called something else. Rule? Maybe rule. Anyway. Or is it the beginning of this Exper, and then you should parse the next operator? Does it go as like the first argument to the Exper in here, or the argument, or this Exper done, and you parse this argument? And so the solution if you were writing this as like a grammar, would be to like left factor stuff so that you don't need any look ahead. Exper equals int, I don't know, more or something, right? Or else Exper, like so. We'll say Exper prime because we're writing a new one. It's unrelated to this Exper. It's a different understanding of it. And then more is like either epsilon, i.e. nothing, or else it's an op and then an Exper. And in this way, when you parse Exper, you definitely know, okay, I definitely had to parse an int. This is the only constructor that starts with an int. And then you go and handle the more. And more looks at the next thing and says, well, either it's an op of Exper, and I mean, I guess like maybe properly we would have written this one first, but it doesn't matter. And in which case it's clear how the thing should parse, or it's like not that, in which case it's clear you just parse nothing. And then you interpret the tree differently depending on how the more works, right? If more is an op, then you combine it into a binary tree, and if more is epsilon, then it's just an int. And I think we like end up doing something fairly similar with our Haskell parser. But we don't actually have to be so formal about it. We're going to be using Parsec. Every time I go back to parsing in Haskell, I'm like aware that everyone thinks Parsec is like old, and like why wouldn't you use one of the modern ones like Megaparsec or Attoparsec? And I always go look and like read what exactly is the difference between them again, and it's always like stuff I don't care about. You know, Megaparsec has better error messages and can track the line that you're on better, and you have better metadata, and it has some more efficient features. And it's like, this is all great if you're parsing 800 line source files, but for parsing a stream of like 7 tokens, I would rather just stick with Parsec, which is, I'm sure Megaparsec is as convenient to use as Parsec. I'm just like less familiar with it and don't want to read the docs. So anyway, we're at some point going to be writing, we're going to be writing something like, I don't know, something that mirrors this fairly closely. Exper is a parser, whoops, for Exper, right? And we haven't defined these types yet, and you know, whatever. We'll revisit it. But at some point, Exper is going to be parens or parens or do. Sure, that seems okay, I guess. You know, x is an int, and then we can say something like Exper of x op Exper, or else pure int x, something like that, right? And so we kind of left biased already by pulling out the int, and then we have, like, it kind of happens implicitly here, and it's I kind of think it's nice that the we have the associativity rules that we do, or associativity, right? Yeah. I always get associativity confused with commutativity, but commutativity is definitely not relevant here. So this will have the effect that there we go. This is a little bit differently because x is not something we should parse. We've already parsed it. So this will look and see, is the next thing an op? And if so, it will continue down this branch of making an Exper out of it. And otherwise, it'll say, no, the next thing is not an op, and we should stop. And just return that int, and go up to like the next level where there's presumably already some other higher level expression that cares about us. So I think honestly we can like we can use this as our parser. I don't think we need to change this text. We just need to define the types around it. We need to define int as well, which I've done a bunch. Although I think it's in Parsec, right? Haskell Parsec char int text Parsec number. I don't think that's what I want. This is in Parsec. And there's all this token stuff, which I really don't need. Parse test, yeah. And combinators are great. Try, I mean, I know all this stuff. Here's all these combinators, but I'm looking for the one that's like specific to character or string parsers and has an int in it, because I know there's one somewhere. Char? Or text? No. Prim? No. Char, one of none of spaces. Yeah. This is okay. Alpha num, great. I know there's one in one of these. It's not in combinator, is it? No. Primitive? That would be surprising. It's probably in string, right? No. But we will want this. We'll want a parsec of string at some point. It's not in token, surely. Yeah, this is completely useless. It shouldn't be an Exper, I don't think. I mean, we could tell it. We could describe our our operator associativity to it, but what we have is so simple. There's no real reason to try to understand that. It's not just in text parsec, is it? That'd be completely wrong. Yeah. Okay. Well, there's no int parser that I can find. It's there somewhere. I'm pretty sure I've found it before and been like, oh, I missed it. Wait a minute. Then there's text parser combinators, Parsec. Let's look in char there. What exactly is the difference between these two? Parsec compatibility module? It looks about the same, right? All right, whatever. Anyway, it's super easy to write read of many digit, like, fine. Okay. So I guess let's get, we probably don't need lambda case, but like, who knows, maybe we do. Import text parsec string, I think? Yeah, string, and we need like a few things. We just need like parser, basically. That's our parser type. It's a string parser with no state. Then we need text parsec char. And we need pretty much all of it, right? It's just a million useful combinators. And we need text parsec, the top level thing, at some point, I assume, to like run it. Let me just look this up. Yeah, parsec t, we don't need most of this. We have a parsec of, but we already have a string parser, so that's fine. Tokens, run parser should be all we need. Let's deal with parse versus run parser. Oh, parse no user state. Okay, so we probably want parse. Oh, and we'll need stuff like try. Well, no, we shouldn't need try, actually. And this is an alternative already, so... Choice, many, one. Okay, those we will probably want, right? Those aren't in char. Okay. Text parsec. What do we need? We need parse, many, one. This might actually be it. Yeah. Okay, that'll do then. And we'll need a bunch of things from char, so I'll let this be my like one unqualified import, so any confusing symbol can be assumed to have come from here. I think it's still kind of bad style to write this, and if I were doing it for work, I would hopefully have an IDE that would handle it for me, but otherwise I would carefully list out all the imports here. So actually, we should just do that, right? And then we don't need this int wrapper here. Okay. Well, I don't know. Why not just put that in int, right? Yeah, of course. So let's just find our type real quick. Data Exper equals int of int, or else it is a bin of Exper op Exper. Data op equals mul or add. I don't know. Let's say plus or times. And that's our Exper type. And we can easily write a parser for int here. Int is a parser for int. Int is read int.read mapped over many one digit. What's it called in Parsec char? Digit. Okay, maybe actually what I'm remembering is that there's a digit that exists in Parsec. And that I should stop having to implement it with like satisfying the predicate that the character is digit from data char, probably. Then we can say parens equals, it's very easy, it's just char. Yeah, we want char Exper char, like so. This is a parser of Exper, not int. I guess our white space is sort of an issue. You know what we'll do? We'll just remove all the white space before we feed it to a parser. What are you mad about here? Variable not in scope? Isn't it in... Did I say imported? Apparently. I thought it was part of... I thought it moved into the prelude when we got fmap and an app here, but apparently not. Bin, yes, you're correct. And then we just need an op parser. It should be very easy. Op is a parser for op. Op is what are they called? Plus char plus or times of char times. Easy. Now, I don't know how these parse, so we're going to do this. It's not telling me redundant bracket, which means I think if I didn't do that, it would parse like this. Yeah, that bracket is redundant, which is horrible. Which is like, parse either a plus or else a times of a char, and, oh wait. Yeah, like, well, actually it's not telling me this is redundant, it's telling me it's wrong, which is true. Anyway, the point is that I don't know how the operator precedence for this is. I guess we could find out, right? We have a REPL now that has Parsec in it. Parse. What's the type of parse? Foo equal parse. Okay, like tell me. Oh my god, it takes a parser and then a string for the file name and then the string to parse. Okay. Parse standard in, let's say, and parse as op standard in of times. I just want to see if that is right. What exactly is foo? That's fair. There's no show instance for that. Case foo of times plus. What? Oh, no. Ah, it's an either, right? It was times. Let's just inline this foo here so we can play with it a bit more. Okay, so we don't need the parentheses, but I'm always a little nervous when I use this operator here that means just ignore, just parse the thing to the right and then don't worry about what the value was at all. And I wonder if it might accidentally, like, you know, we would parse a times and then, you know, wrap it in times and then, like, ignore that. But, like, if it were parenthesized differently, I think it might mean that. But clearly it doesn't, so great. What are you warning me about here? This looks right. Parse is redundant. Oh, because I'm not using it yet. Sure. Okay, and let's test out a bit. Let's derive show for these, I guess, just so I can confirm that they work. And we can then say parse Exper standard in of let's say this. Well, this one actually, because that will make it clear that we got the ordering right, the associativity, right? Ah, it'll fail because we didn't tell it about spaces. It worked. Ah, of course. It said, okay, I got up to 2, but then there was some weird stuff I was not sure what to do about, so I gave up. Fine. So it's an int of 2 added to no. Well, yeah, we got this backwards, didn't we? Because the 2 is supposed to be in the deepest tree. If we look back at the problem statement, right, this should be an entire sub-expression and the stuff on the, so okay, we got something wrong. Oops. Somehow, but I thought I was pretty clear on this. Just by putting it first, it should prefer that one, right? Ah, I see. So the problem is it said, yes, I successfully, I went down this path and I succeeded, right? I found an op and I made it to bin for you. So I made this right biased. What was I supposed to do to make it left biased? Or maybe I have it backwards, I don't know, but whatever. We could write these in the other order, and I think then it would The problem is it would then like always like let's say we swap this, right? This would of course still be a valid parser, but PureX always succeeds, so I believe it would never go down this route. It would just say, "Oh, I found you a 2. Let's confirm whether that's true." You know, so that's not right. Let's confirm at least that we handled the parentheses right before we start to. So if I write this, it should give us what we actually wanted, right? Which was, whoa, that's not right. What happened to the other 7? What? Oh, well. I mean, I guess that's fair. We didn't make it possible to combine parens or ints, did we? So what I should have written was this. Like so. And now our parens work, right? We said it's a bin of adding together 2 and 7, and then adding the result of that to 7. And that's how it should parse without the parentheses, but it's clear that the parentheses now do work, right? They can override the default precedence. It's just that we haven't gotten the default precedence right yet. So I'm pretty sure I should not just write like a recursive call to Exper here. That would be a mistake. I was never very good at like understanding operator precedence in parsing. I'm not even that good at it in my like human brain as like understanding it written. When I say like 2 plus 5 times 7, I'm like, wait a minute. Times binds tightly, right? What does that mean exactly? And I have to remind myself, yes, it means you multiply 5 by 7 and then the 2 is added later. So how do we get it? Like, what is the problem here? The problem is that this X thing is unwilling to consume more stuff, right? So like you could write something wrong, like you know, bin of Exper prime, like so. Exper. Or else int or something. I don't know. Or parents. But the problem is this never makes any progress. It always tries Exper prime right away, which makes it try Exper prime, which makes it try Exper prime, and it never consumes a character. So I feel like we have to parse an int, but then how do we like tell it that that int may be, well, maybe what we can do is to actually not parse the structure of the tree immediately, but rather parse a list of operator and item or single or something pairs, and then build in the associativity by hand with a fold L? That seems okay. Right? So what if we said, we'll just leave Exper alone as a model for thought for the moment, and write Exper prime, if I can type properly. There's a parser for Expers. And here's what Exper prime is. Exper prime is, first, we parse a single simple, we'll call it, where simple is a non-binary. It's just like an int or a parenthesized expression. And we'll define that in a moment. It's the same as this, right? But I'm giving it a name here because we're going to need to reuse it. And then we say, let's say more will be many. I guess we need many of I guess I will need to tuple together an op and a simple. And then we will fold, and I'm pretty sure we want fold L, because fold R would give us the same problem we had before, right? Yeah, it would just be weird. We want fold L in, I guess, where our initial accumulator is L, and then we have more, right? Import data list fold L, where simple is parens int. Okay, everything here is wrong. Not sure why yet. Oh, uncurry bin because we have tuples? No, it's still upset. That's true. Bin is a 3-argument function, isn't it? Okay, well, let's just define a new function here, because we'll call it build. Build is a function that takes an accumulator and a pair of op, well, we'll call it left. Right is bin left op right. Oh, this shadows, who cares? So, okay. Is this correct? If I said to parse Exper prime of this, it says, aha! Yes, you've got a bin where on the left side you're adding together 2 and 7, then you add the result of that to 7. So that's much better. This is what we actually wanted. I don't know what the right way to have done this was. This doesn't feel like it. Oh, it also it only happened to work because I was parsing a small enough expression. To really test it, I should have made this Exper prime. I might have been very confused. Fortunately, now that I've renamed Exper prime to Exper, it's correct again, but it was wrong for a moment there and just happened to work by luck. And so that's fine for parsers. And now let's write our evaluator, which is much, much simpler. Eval is a function from Exper to int. Eval of int x equals x. Eval of bin of x op y equals f x y, where f equals case op. Well, let's just inline it, right? No, I don't know. Yeah, sure. Of course. Case op of I don't know. We should give it a where. Case op of plus times. We could write this on multiple lines, but it's so simple, like why bother, right? Hello? Ah. We have to evaluate these things as well. You could, never mind. You could write a fancier thing, like this could be a catamorphism where the results have already been done for you. I do have recursion schemes in scope, I guess. But I don't really want to relearn how that works today. So let's just confirm that if we now said eval of this Exper. Oh, it's not Exper prime anymore. I didn't read the text. Ah. Sure. You know, screw you. I'm just going to go grab this and say eval this for me, please. 16. That looks about right. And I think we are then about ready to write prepare and then parse 1. Turns out I don't need many 1 after all. I'm used to using many 1 instead of... Oh, I did need many 1. Parse is what's redundant. Well, we're about to use that. So prepare is map parse the problem is that, well, we haven't even defined our input type yet. It's a little actually tricky. Maybe part 2 will ask us to parse it differently somehow. It's hard to imagine actually what it could do that would be different. Maybe this is maybe part 2 will be like, oh, you had the precedence wrong. It's actually always left associative. Which would be very easy for me to fix, but it would be kind of silly for the input to be the parsed string, right? In that case. So let's just have the input be a list of strings where we've removed all the white space. This is actually correct then. We won't do any parsing here in input. Prepare is map filter not equal space lines. Cool. That looks right. So now our input, our parser doesn't have to worry about spaces. This is our lexer. It's very, very sophisticated. Filter, not space. And part 1 is something like sum map eval dot. I mean, like, what do you do if something fails to parse, right? You kind of have to. Parsing can fail. We have to figure out how to admit that properly. Let's actually just like make it be an either. Yeah, that makes more sense. Parse error or int, and we need to import that from here, I guess. Parse error. Because like, what was yeah, parse error. Cool. That's the type. So we'll fmap sum, I guess, and then we will traverse eval parse Exper. Oh, it needs a standard in. It type checks. Let's try it. I'm a little skeptical. It's a number. I love it. Let's try it. That's a large number. This kid's in an advanced level class. Okay, well that's correct. That's very reassuring. Anything I need to remove? I don't need lambda case. Okay. Git add day 18 part 1. They finished part 1. Next section, advanced math. Oh no. Now addition and multiplication have different precedence levels, but they're not the ones you're familiar with. Instead, addition is evaluated before multiplication. Okay. That's very sad. I don't like this at all. Because it means we can't just do what we did before of being accidentally left associative. Or accidentally right associative. Again, I don't know which is which. We have to be fancy. But okay, I mean, so I think in a sense, is this like, it's not exactly easier. But this reminds me again of like, the classic way to solve this is to say that, you know, normally you would say, and a multiplication can't contain any additions in it, right? So you would say like Exper is either like a parenthesized Exper or actually, this is kind of funny. By the way, I forgot to put more here. But this is exactly what I did. I left factored the int and then just parsed a sequence of Exper more, or op expers. Huh. I didn't really realize how closely it reflected this. I was like, oh, we won't have to do this. But then we did. So, and then you can say it's a like mul times mul or something, right? We could call this a product or whatever. And then a mul is either well, I guess or int. Right, this is before we've done the left factoring. And mul is then the same thing, I think. Or else add plus add int. Is this right? So the point here is that you parse all of your multiplications first without being allowed to descend into additions, and then once you do descend into additions, there's no way back to multiplication. So if we wanted to parse like 1 plus 2 times 3, how would we parse that? Well, it's not parenthesized. It's not just an int. Maybe it is actually. So no, it's a, and it's not a mul either, because the first op is an int. So it's a oh, where did my, oh, I gave these weird names. I think we would just do this. No. Yeah, something's wrong here, actually. This should just be a single mul. And a mul is no parentheses this time. It's just an a mul. Jeez, my throat's been. Anyway, mul times well, associativity though. One of these should be an add. Ugh. Like, there's got to be some way to get down to add. And it has to come from mul, so we've handled all the times operations already, right? So I think it has to be the other way. Do you do the higher precedence ones first? Or the lower precedence ones, like plus, because they need to span? I think that's right. I guess we would do like a sum times a mul, basically. No, this is absurd. Right, we're starting with an add. Oh my god. So let's say we started with a sum, right? This makes, actually, oh, that would be for normal arithmetic. Normal traditional ordering. Right, we would start, it's a sum. At the top level, we have a sum. That makes sense. Because you typically express stuff as a sum of products. Yes, okay. And a sum is a sum plus an Exper, I think, to get things ordered in like the right way. Or it could be just a mul, right? A single mul. And then we would say, or let's call it a product. And a product then is a an int times a product, and that's it. This seems right. Now, we still have the problem of requiring look ahead, because our product is not right here. This needs to be able to handle being parenthesized, doesn't it? Otherwise, you can never multiply anything by a parenthesized expression. Well, okay, we could add that in. This still isn't quite right, even if I fix this, is it? I don't know. Parent. There you go. This isn't quite right because it's illegal to have a sum where the left side is redundantly parenthesized in this way. Oh, I was going to write and actually it would be simpler if we put Exper plus sum here. Actually, if it's just possible for sum to resolve down to being parenthesized, that would be fine. Right now it can't. Well, it can because we're like, I don't know. Oh, maybe this is fine actually. No, but now product still can't have a left side be parenthesized. Oh, so what do you call something being multiplied with something? A factor? Yes, okay, that's how this should work. It's just a factor, right? And then we say, well, okay, first of all, we don't need all this junk. A factor is an int or a parenthesized expression. And now I believe this is rich enough to handle exactly what we were supposed to handle. Yes? An Exper is either a parenthesized expression or a single int. Oh, interesting. It could just be this int or parent is like shared. So we could say it's a sum, or else it's a factor, and like that's it. Yeah, that seems right. And if it's a sum, then it's expression, which again could be parenthesized, could be anything. Actually, yeah, this seems fine. Plus a sum, or else it's a product. which means that it has no more addition in it, right? Yeah. So once you've handled, yeah, okay, and then, so for a product, it's either a factor times a product or just a factor. And factor is an interparent. So the last problem is that of look ahead. I believe we could use this grammar and just translate it into Parsec and it would work, although of course we would want to switch the precedence because we made plus be the top level operator here. But it would be sort of nice, because Parsec, you can just say, Parsec, go ahead and use look ahead for me, and it will. But it's not terribly efficient to add backtracking when, in principle, I don't think we need any here. If we were to factor things out a bit better. The problem is that sum, when it looks at its Exper thing, like, it has a different, it has to take one of two different paths, but the first character it's looking at is the same, so it has to maintain ambiguity for a while. So I think the principled thing to do would be to factor this out again in the same way that we did up here with more, right? And I think that is a good exercise to do. So like, the thing is, we don't even need it anymore because any ordering would be fine. Oh, but yeah, I mean, okay, we would need look ahead to get any legal ordering, which kind of stinks. I don't know. Let's just do it with look ahead and then maybe come back to it someday. So I think we'll suffix all of our parsers with the number 2, just to make it clear. Well, actually, op can stay the same, and int can stay the same, but parens and Exper will need to. Actually, does parens need to change? Yeah, because it has to go to our Exper 2 instead of, okay. So we'll say Exper 2 is a parser for Expers. Oh, you know, so I don't get confused, let's actually do the swapping here. It's a product or else an addend. And a product is an Exper times a product, yes, or else just a product. And an addend is a product. No. We'll call it single. I don't know. Single plus addend, or just a single. And this is our single here. Oh, actually, this addend should have been called sum, I think. No, I don't know. Is this wrong? Did I do something wrong in the first one of these? Sum recursed with itself and then called the other one here, and I didn't get that right in this. Yeah, this should be a sum. And this is a sum. Like that. And this single then can be called addend. Which is actually what I wanted. Yes, okay. So there's definitely ambiguity here, but I think we're just, as I said, going to let Parsec handle that. As a parser for Exper, Exper 2 is, well, it should be easy. We'll just write it down. Product 2. We don't have a product 1, but again, I want them all to be suffixed with 2 for clarity, so I don't get them mixed up. I don't know. The only one I need to share is paren. I guess that's fine. You know what I could do is move parens into here. There you go. Now I don't need to give anything to except the top level Exper. Let's just put all this shit in where clauses, huh? Just like this guy did? Yeah, that makes sense. Where, well, let's do paren first, since it's easy. Actually, we can reuse this, right? Exper 2. Now product is gonna need Parsec's try now. We didn't need it before, but now we do. That's the thing to say. Go ahead and do backtracking for me. Try of Exper 2 bin Exper 2 op Exper, no, product is what we said to write, or else it's a sum. Sum is a bit awkward because product and sum are both in the prelude, and I'm using sum in this file. Oh, but I can just shadow, it'll be fine. Next we have sum is try of bin addend. Oh, not op. This can't just take an op. It needs to take a times plus sum. And if that did not succeed, then you should be an addend. And an addend is simple enough. It is just an int or a paren. Now we need times, which is just very simple. It's times of char times plus is plus of char plus. It's mad about shadowing, but that's okay. So suppose then that we test this. Parse Exper 2 of standard in, let's say 2 or 1 plus 2 times 3. It breaks. Great. Hello? Does okay, interrupt works. It just took a while. So, why would you break? I mean, I guess that makes sense. Right. We do have to left factor it because otherwise it just has infinite left recursion. Okay. So we'll have to do the same trick we did up here. let's just define a helper try go, I guess, where go equals do. And we're gonna parse, I guess. Well, okay, let's have this for reference. I think the thing we're parsing here is an addend. Is that correct? We want to parse any number of additions and then multiply by something, right? So left addend more many yeah. Or not addends. We want to parse sums, right? Yeah. And we want to multiply them all together. Okay. And at least in this case, we know that all the ops are just times, right? So we can just parse many of some, like so. And then we can say, and at this point the associativity doesn't actually matter, but we might as well get it right. Fold L I don't know, P left more. P is P of LR equals L bin L times R. Okay, and we have to do the same thing for sum, but using addend. Try go or addend, where go equals do. Left will be an addend. Oh, this seems like a totally important reusable pattern, doesn't it? But for now, I just want to get it right. Many char plus addend pure old L s left more s lr equal bin L plus R, right? Ah, I'm not using times anymore, so I can't figure out what types they should have. I can just throw them away. And you're mad about shadowing, which is fair, but I don't care about your feelings. Okay, so now it said you have a bin, and the bin is multiplying together the sum of 1 and 2 by 3, which is what we wanted. This is backwards from normal parsing, but that's exactly as intended. And to confirm that it has associativity right, we can write it the other way and see that it says multiply 1 by the sum of 2 and 3, which is what we wanted. Okay, now we can also factor this out. We'll write a function called run, which takes a parser for Exper and returns the function from input to either parse error int. Told you we want to parse it differently. Anyway, and just do this. Run equals There you go. So part 1 is just run of Exper. Is run of Exper 2. There we go. And how do I run it? Like this. It's a larger number, but it's still a number. That's good news. That's the right answer. Okay. We'll commit this and then see if there's any easy cleanup to do as a follow-up commit. Part 2. Because, like, this pattern is so, like, I can extract this in the most ridiculously simple way, right? At least to be shared between product and sum. Whether you can do it in Exper 1 is a little bit trickier because... No, it's fine, right? Yeah, it's the same thing. So let's say, I don't know, chain. I think chain means something specific in parser lingo, but I don't know what it is, so it's fine with me. So chain takes... I guess it takes a parser for expressions, which it will use here. Parser Exper will be passing simple, and we'll also be passing this, which is a parser for A. I don't know what that A is. And a function which combines an Exper and an A yielding an Exper, and this will give us a parser for Exper, I think. So chain base more repeated combine equals do. L will be base, more will be many repeated pure of fold L combine L more. And then we can just say, we can remove this do completely, and it's a chain of simples followed by these combined with build. And actually it kind of seems more aesthetic to put the build first. Just like, I don't have a good reason, but it feels like such things often take the function argument first, and there might be a good reason for that. Can I? There might be some way, some key prefix, like if I put a meta 2 before this and then gave the transpose key, would it transpose it by 2? I'm a little scared because, nope. What if I did it over here? Nope. All right, I'm dumb. Anyway, I'm pretty sure there's some way to do that. Because as you've seen, I have a keystroke in Emacs that will swap to adjacent expressions. And if you want to swap it, but like leaving one in the middle, like swap it by 2, I'm sure that there's like transpose S expressions with a non-zero prefix argument. Effect is to take the S expression before point and drag it forward past argument other s expressions. So that's not actually, I didn't want any of those. I wanted to drag something backward by 2, and it doesn't seem to exist. Okay. Anyway, I'm a little scared to do it because the key bindings in Emacs for giving prefix arguments are very, very close, and indeed overlap with my key bindings for like fiddling with my recording software and stopping recordings and so on. So now we can say chain. This will be much simpler, right? Try chain sum this, this, and p. And we can throw away go. Oh, p is first now, I forgot. Why are you mad? Ah, we need to remove the many as well. Yes. And we can do the same thing. Chain s addend. Okay. That's rather nicer, I think. Yeah, so let's just confirm that that still runs correctly. Yeah, looks right. Day 18, factor out chain operation. All right, that's all for today. Hope you guys enjoyed this little detour into parsing. Thanks for watching, and I'll see you next time. Hello, welcome back. I changed my mind. We're not done yet. I realized that what I was implementing, like I called it chain on purpose because I know there's something sort of related to chaining in parsers, and what I'm doing seemed sort of similar to that, but I didn't really understand what chain was. It's a thing with like I've seen people implement parsers themselves, they implement chain. I was like, I didn't really understand what the point was. And I was like, well, I clearly need this thing, and it seems sort of related to the concept of chaining, so I'll call it chain. But if I had like gone and looked at the Parsec documentation, I would have seen like exactly the function that I just implemented. In particular, chain L1 is what I'm using here. It parses one or more expressions of occurrences of P separated by op. Returns a value obtained by a left associative application of all functions returned by op to the values returned by P. This parser can be, for example, used to eliminate left recursion, which typically occurs in expression grammars. And this is like exactly the problem that I had, right? It was like I have this left recursion, and I had explained how we could factor it out. I did it by hand in here in our earliest example, where I said, okay, we have this like left recursion problem, and so you can fix it by factoring out this int and then handling more, which is a pair of things. And then I implemented it in terms of like parse a thing, then do many pairs of things, right? And then later I said, okay, well, we can generalize that to chain. What I didn't realize was that the chain thing that I did was exactly chain L1. Sort of, almost. Where's op? I see, we need, so it parses functions from A to A to A. So to use chain L1, we should change things the tiniest bit here, right? Because in chain, I was taking an A just because I didn't really care. Yeah. So really, I should throw this entire nonsense away and use chain L1, which, where is it? Text Parsec Combinator. So chain L1 takes its arguments in what order? It wants a parser for P first, and then, okay. So chain L1 is simple, and then it needs an op. So I think all we want to do now is change. We can just change what op is. Op is a parser for Exper. And op is bin over this whole thing, where bin f. Actually, is bin just flip of bin? The capital bin? Yeah, it is. Okay. Well, we can just do this then, right? And then we can just say op, I think, right? And this is just chain L1 P well, it takes a sum, and then here we return P. No, hang on. Right. We're meant to P F mapped over parsing a char. Okay, good. Chain L1 addend S over this, right? S. What's wrong with S? Oh, we still have this, which should be gone. What are you mad about here? A to reduce. Fine, but I kind of like it the way it is, if that's okay with you. Also, it's flip bin plus. We could reduce it more. We could inline it. I'd rather leave it out if that's okay. And if we now, oh, I did some rewriting of my commits. Doesn't matter. Stack run. Yeah, we get the same answer. So this is much nicer, right? If we look at git diff, we just imported chain L1, made a tiny change to op, very small, and then we were able to throw away chain. And honestly, the parser that we got was kind of nicer anyway. Yeah, so I'm happy with this. What does chain L without chain L1 do? Ah, it takes a default value for if it didn't parse even a single time. So you could say a sum is like parse of, you know, an Exper with the plus parser with default of 0, for example. Okay. Day 18, don't re-implement chain L1. So I'm really happy with this because I finally understand what the fuck chain L1 and chain R1 are for. I've understood parser combinators and seen these and been like, I don't really know why you would need that. And today I rediscovered it by like running into the problem that they need, solving it by hand 3 times, and then seeing that you can generalize it, and then seeing someone else already had generalized it, and for exactly the reason that I needed it. And like, I get it now. And we could have chained R1 if we wanted it to go the other way. Amazing. Okay. So that's all I wanted to show you today. Now we're really done. Thanks for watching, and I'll see you next time.